Hello there, and welcome. Tonight, we're stepping off the steady march of seconds and into the strange terrain where time itself starts to bend. What if every clock you've ever looked at was lying to you, not broken, just incomplete? What if your memories of yesterday, your plans for tomorrow, and the instant you're living now all exist at once, like pages in a single endless book? From Einstein's warped space-time to wormholes and quantum entanglement, time travel might not be fantasy. It may already be written into the fabric of reality. And while you're settling in, before your eyes grow too heavy, I'd love it if you gently tapped subscribe or pressed the little hype button YouTube recently added. It's a small click, but it helps keep these experiments and explorations orbiting out into the algorithm. You can also leave a comment telling me where you're listening from and what time it is in your corner of the night. It's oddly fascinating to see where people are drifting off with us, scattered across the world like stars across the galaxy. Now take a deep breath, let your day drift away, and let's travel together into the quiet corners of the universe. If you could step outside of everything you've ever known, beyond the hum of cities, beyond the stars themselves, you'd find that the universe isn't built from pieces and parts. It isn't stitched from space and then sprinkled with time. It's one continuous fabric, smooth and silent, stretching in every direction and every when. Einstein called it space-time, a single sheet upon which everything, planets, light, memory, and even you, leave their gentle impressions. Imagine a sheet of velvet suspended in the dark. Place a marble on it, and the fabric dips. Place a planet there, and the curve deepens. That curve is gravity, not an invisible hand pulling things down, but a distortion of the very stage everything plays upon. When Einstein first described this, it sounded like madness. For centuries, people thought of time as a steady drumbeat, untouchable and absolute. Seconds were seconds, the same for kings and shepherds, for mountain and sea. But Einstein saw something more intricate. That time could stretch, slow, and twist, depending on how you moved or where you stood. Speed up enough, or fall deep enough into gravity, and your clock no longer matches the one you left behind. On mountaintops, time passes just a little faster than it does at sea level. A few nanoseconds each day, tiny, almost invisible but measurable. Astronauts circling Earth experience time more slowly than those of us down here. The faster they go, the heavier their watches feel to the universe. Every orbit is a small leap forward, a whisper of the future slipping through their fingers. When they come home, their bodies are younger by fractions of a second. It's a kind of time travel, not through fantasy, but through physics. It's humbling, isn't it? To realize that time isn't the river we thought it was, flowing steadily from past to future. It's a landscape, with valleys and ridges carved by motion and mass. Light itself bends as it passes near stars, as though skimming the side of an invisible hill. Even the ticking of your heartbeat, the rhythm of your breath, depends on the slope of space-time beneath you. We are all falling together through a gentle curvature we cannot see, held in a cosmic embrace so perfect it feels like stillness. Einstein's revelation gave birth to a strange new view of existence, the block universe. In this vision, the past hasn't vanished, and the future isn't waiting to be built. Every moment that has ever been, or ever will be, still exists, stacked together like pages in a timeless novel. You are simply reading through them, one instant at a time. Right now, as you listen, there is another version of you still waking up this morning, another still years away, in the future, and another who hasn't yet been born. None are illusions, all are coordinates on the same map. Think of a film reel. Each frame holds a frozen image, motionless and eternal. The illusion of movement comes from your perception, your consciousness traveling from one frame to the next. If you could step outside that reel, you'd see the whole story at once. That's what the universe is. A story already written, every second existing side by side, eternally. The sensation of time passing is simply the light of awareness moving across it, like sunlight sliding down a wall. This doesn't mean life loses meaning. Quite the opposite. It means that every moment you've ever loved, every word you've ever spoken, still glows somewhere within the structure of space-time. Nothing is erased. Your laughter, your fears, your first memory of rain, all are carved into the geometry of existence. Even the instant this thought crosses your mind will remain forever, suspended in the cosmic fabric like an imprint in wet clay. And yet, we still move, we still age, we still feel the pull of clocks and calendars. Why? Because motion through this fabric is relative. The universe doesn't have a single tempo, it has a symphony of them. A star near a black hole may live and die in what feels like a blink, while light passing through empty space drifts for billions of years without noticing. For photons, time doesn't exist at all. They are born and arrive at their destination in the same instant. In their world, the journey and the arrival are one. That's the quiet magic of Einstein's discovery. Everything we think of as separate space, time, gravity, existence are threads of one immense tapestry. When a planet orbits a sun, it isn't being pulled. It's simply following the curve of the fabric. When you fall toward the ground, you're tracing the natural line of space-time beneath your feet. Even your memories, stored in the folds of your brain, are tiny ripples in that same universal cloth. If you could somehow tug on the corner of that fabric, pull it toward you or twist it just right, you could change your relationship to time itself. Move fast enough, and the minutes stretch. Drift close to a black hole, and the rest of the cosmos would seem to race ahead. To those outside, you would appear frozen in an eternal moment. To you, it would feel like normal breathing. Time, patient and obedient, would bend around your path. That's where our story begins, not with machines or paradoxes, but with this simple, stunning truth. Time is not a ruler we march along. It's the stage, the canvas, the unseen ocean beneath all things. And within it, we are both waves and watchers rising, falling, and folding back into the same endless fabric that carries every second home, high above the curve of Earth, where the sky deepens into black and continents glow faintly beneath drifting clouds. Astronauts drift through a world where time itself begins to stretch. Up there, seconds do not behave the same way they do here. They loosen, widen, and slip ever so slightly apart. The difference is small, mere milliseconds over months, but real enough that it must be measured and corrected. The faster you move through space, the slower you move through time. It's one of the strangest truths in all of physics. Motion is not only a journey through distance, but through the very rhythm of existence. Imagine two identical clocks. One stays on Earth, steady under the pull of gravity, ticking the heartbeat of our planet. The other boards a spacecraft and circles the world at over 17,000 miles per hour. From the astronaut's point of view, their clock ticks normally. They sip coffee, adjust instruments, watch the horizon roll by, and nothing seems unusual. But when they return home, the two clocks disagree. The one that traveled through orbit has fallen slightly behind. It's as though time itself bent backward to make room for their speed. This is time dilation, an elegant consequence of Einstein's theory of relativity. When you move through space, some of your motion is borrowed from time. Since nothing can move faster than light, the universe preserves that cosmic speed limit by redistributing what you have. If you accelerate through space, you slow through time. A person racing close to light speed would experience minutes, while years passed for those left behind. To them, the journey would feel brief, but to the universe, they'd have skipped across decades. It sounds like fiction, but every satellite orbiting above us is living proof. The global positioning system, those invisible eyes guiding our maps, our planes, our deliveries, relies on atomic clocks carried by spacecraft. Because those satellites move so fast, their clocks tick a fraction slower than clocks on the ground. At the same time, being farther from Earth's gravity makes them run slightly faster, since gravity itself also stretches time. One effect cancels part of the other, but not completely. Engineers must program in relativistic corrections every day. Without them, GPS signals would drift miles off target within minutes. The maps on your phone work only because humanity has learned to tame the flow of time. Up there, an astronaut's heart beats the same, but the universe listens differently. Their seconds are longer, their minutes more generous. In the grand story of the cosmos, they age more slowly than the people waiting for them at home. It's not a trick of perception. It's the literal warping of space-time by motion. Time does not march. It flexes, bends, and curves depending on how swiftly you move or how close you are to mass. Think about it. At every moment, the speed you travel through space and the speed you travel through time always add up to the same number, the speed of light. Sitting still, you race through time at full speed, aging at the normal rate. Start moving faster through space, and you borrow from that temporal motion. Your journey through time slows down. The faster you go, the less you age. For light itself, which moves entirely through space, there is no movement through time at all. To a photon, the moment it leaves the sun and the moment it strikes your skin are the same instant. For light, existence is an eternal now. Astronauts glimpse a fragment of this eternal now each time they peer from their windows. The blue of Earth fades below them while the stars beyond remain fixed, cold, ancient. They orbit our planet 16 times a day, watching sunrises and sunsets sweep past like waves. Yet their internal clocks drift, just a breath slower. If they lived in space long enough centuries, perhaps they'd return to find Earth older than their own bodies. It's a tiny doorway into the future, open not by magic, but by motion. Even here on the ground, the effect never stops. Every moving car, every flight, every breath you take is accompanied by the faintest skew of seconds. The difference is immeasurable to us, but not to the universe. Time dilation is always present, everywhere, gently sculpting the way moments unfold. You're already a time traveler, your life unfolding through 1,000 imperceptible distortions. There's something poetic about that. The faster we reach outward, the slower we exist. In chasing the stars, we lengthen the thread of our lives, even if only by a fraction. The cosmos rewards motion with endurance, yet demands energy in return. Time, it seems, is a quiet accountant, balancing every equation with exquisite precision. If we could ever harness this principle fully, if we could build vessels to sustain speeds near light itself, we could move so fast that decades would pass outside while only days passed within. The stars would change, civilizations might rise and fall, and yet we would emerge scarcely older. To everyone else, we'd be ghosts from the past, stepping out of the future's doorway. For now, though, time travel remains subtle, hidden in milliseconds and decimals, recorded in the readouts of orbiting clocks. Still, it's happening constantly. Above you, satellites drift in slower seconds. Below you, deep in gravity's grip, Earth's core ticks at its own pace. Between them, humanity sits balanced in the middle, our days shaped by a rhythm that is never truly uniform. Perhaps that's the most wondrous truth of all, that every tick of every clock is a local language, unique to its place in space-time. The universe doesn't keep a single time. It hums a chorus of them, layered and shifting, overlapping like waves in an endless ocean. And whether you're grounded to the earth or floating among the stars, you are part of that music, swaying gently to a tempo written by motion itself. If you could stand on the edge of a black hole where light itself begins to hesitate, you would find that time no longer behaves the way you remember. Each heartbeat would stretch like taffy. Each second would spill and bend until minutes and hours blurred together. To the rest of the universe, You would seem to freeze, suspended forever at the rim of darkness. But from your own perspective, everything would still feel normal. Your pulse would keep its rhythm. Your breath would rise and fall. The distortion belongs not to you, but to the world around you. This is gravity's secret elevator, a one-way descent into slower time. Einstein revealed that gravity is not a force pulling downward, but the bending of space-time itself. Mass curves the fabric, and everything that falls is simply following those curves. A black hole is what happens when so much mass is packed into such a small space that the curve becomes almost vertical. It's not a hole. Not really, it's a place where space falls faster than light can climb out. The deeper you go, the steeper the slope. Time stretches in sympathy, warped by the same geometry. Imagine floating above a black hole the size of a city. From your vantage point, the event horizon below looks like an ink-black mirror. Stars behind you smear into rings of light as their photons are caught and bent. If you were to lower a clock toward that horizon, its ticking would slow. You'd watch each second lengthen until, just before the edge, it seemed to stop altogether. To you, the clock would appear frozen in time, balanced forever on the threshold. But the clock itself would disagree. To the clock, to whatever travels with it, time continues. It crosses the horizon, vanishing into the dark, still moving forward from its own point of view. If you fell with that clock, you would feel no sudden jolt, no drama, no boundary at all. The universe would simply rush by faster and faster as the black hole's gravity twisted space-time around you. In those final moments, you could look outward and see the future unfold at impossible speed. The stars would age, galaxies would turn, and perhaps even the universe itself would drift toward its distant end, while you remained mid-fall. Your descent would be your eternity. For the rest of existence, you'd appear frozen in the same instant forever. Neutron stars, though smaller and less mysterious, offer their own glimpse of this strange effect. They are the crushed remnants of once massive suns, so dense that a single teaspoon of their matter would weigh billions of tons. Stand on one, if you somehow could, and a second of your life would pass more slowly than a second for anyone far from its surface. The gravity would warp not only your body but your experience of time itself. To someone watching from orbit, your movements would look sluggish, your voice drawn out like an echo underwater. To you, nothing would seem amiss. You'd simply exist within a slower current of the same cosmic river. Every massive object has this influence, though we rarely notice it. Here on Earth, gravity already tugs on time just enough that your head, being farther from the center of the planet, experiences time slightly faster than your feet. The difference is microscopic, but real. The universe measures it with exquisite precision. You are taller in time at the top than you are at the bottom. It means that each day, your head is already living a fraction of a second further into the future than your toes. Gravity keeps us tethered not only in space, but in when. This connection between mass and time reveals something profound. The more a body bends space-time, the more it controls the flow of seconds around it. Near a black hole, the bending becomes so extreme that the concept of future splits in two. One path leading inward toward the singularity, and one stretching outward toward infinity. For someone hovering safely outside, you could stare at that edge forever, waiting for your friend to fall through and never see them vanish. They would seem to fade, their light reddened and slowed until it dimmed beyond sight. From their perspective, though, they would have already crossed over, watching you drift faster and faster into some unreachable future. Both views are true. Both coexist. If you could somehow survive the fall and watch outward, you might witness the entire history of the universe in a single glance. Stars being born, galaxies colliding, civilizations rising and falling, all compressed into one accelerating moment. The horizon of a black hole is not just a border in space, It's a fracture in the flow of time. Beyond it, the rules collapse into silence. Perhaps that is why black holes are so mesmerizing. They are the closest thing we have to an edge, not of the universe, but of meaning itself. They remind us that time, for all its steadiness, is as fragile as glass when gravity presses too hard against it. Even here on Earth, we are passengers in that invisible elevator, riding gently through curved space-time, each of us falling together towards something we can't quite name. So when you look up and see the night sky, remember that every star is slowing time around it, every planet bending it just slightly. You are surrounded by a million secret clocks, each running at its own tempo. The cosmos isn't synchronized. It's alive with variations, with pockets of slow and fast, with folds and curves that stretch seconds into infinity. And somewhere out there, on the edge of a black hole, time itself is still falling, endlessly, into the dark. Two children stand side by side beneath a quiet sky, watching airplanes drift like silver fish above the clouds. They're twins, born only minutes apart, sharing the same laughter, the same curious eyes. Years pass, and one of them grows restless. They dream of leaving Earth, of seeing how far human hands can reach. The other stays, rooted in familiar soil, measuring life in seasons and sunsets. When the day finally comes, the traveler boards a ship capable of something extraordinary near light speed. Engines roar, and with a blaze of fire, the twin vanishes into the black sea of space. The one who stays behind waves until the sky swallows the flame. To the traveler, time flows as gently as it always has. They eat, they sleep, they dream of home. Days become months, then years. Yet the faster they go, the slower time passes inside their ship. Their heartbeat, their breath, the tiny ticking of the onboard clock all stretch into longer intervals. Outside, light from the stars bends and reddens, and the view of the cosmos warps into tunnels of color. It's a calm kind of strangeness, one that doesn't feel wrong until they think of their twin back on Earth. For them, only a few years might pass. For the one they left behind, entire decades could slip quietly by. This is the twin paradox, a riddle that seems impossible but is completely real. Two people, identical in every way, can live through different amounts of time. The traveler returns younger, their skin smoother, their body years fresher than their siblings. The paradox is not a trick of language or logic. It's the way the universe truly behaves when motion bends time. Einstein predicted it long before anyone could test it. Speed and gravity, he showed, are two hands that can stretch or compress the fabric of space-time itself. Imagine what it would feel like to come home after such a journey. The ship descends, landing among cities that have changed their faces, under skies filled with newer constellations of light. The traveler steps out and looks for something familiar, but everything is slightly off, as though the world has raced ahead while they were standing still. Their twin, once their mirror, is now older, their hair silvered, their voice softened by the weight of time. The reunion is beautiful and unsettling, proof that time is not a constant flow, but an elastic thread, stretched by speed and tensioned by gravity. It's tempting to think of time as a straight road, but the twin paradox shows it's more like a fabric that folds and flexes around motion. For the twin who stayed on Earth, time flowed normally. Their life unfolded at the usual pace: meals, work, laughter, sorrow. But the traveler's high velocity carved a different path through space-time, a diagonal shortcut through the same reality. Their journey wasn't simply through distance, but through time itself. When they met again, they were both correct in their measurements. Each lived their seconds truthfully. It's the universe that allowed their stories to diverge. This paradox has been tested, not just in theory, but with precision instruments. Atomic clocks flown on fast-moving planes return slightly younger than those left behind. The same happens with GPS satellites circling Earth. They experience time more slowly due to both speed and weaker gravity. Without constant correction, your phone's navigation would drift miles off course each day. These machines, tiny travelers in orbit, prove the pond of same truth the twins revealed. We are already living inside a cosmos where time can stretch, and we can measure it. There's a quiet poetry in it. The faster we move, the longer we linger in youth. If a spacecraft could reach a speed close to light's, a human aboard might live a few years while centuries pass outside. They would sail into the future, not as fantasy, but as a natural consequence of physics. To them, nothing strange would happen. They'd simply be living within time's slow current, carried by the gentle drag of motion. But to those watching from Earth, they'd appear as ghosts of a different century, stepping out of history itself. It also means that every motion you make, even the smallest one, changes your relationship to time. Each heartbeat, each walk, each turn of the planet shifts your seconds ever so slightly. You will never experience time exactly as anyone else does. Each of us lives in a private tempo, a personal drift through the dimension we cannot see. Time isn't one river carrying us all together. It's a web of smaller streams, each winding subtly on its own. The twin paradox isn't really a paradox at all. Once you understand this, it's a conversation between two perspectives, each valid in its own frame. The traveler says, "I lived 10 years." The one who stayed says, "I lived 50." And the universe, with quiet patience, agrees with them both. Each followed the natural flow of their own space-time, guided by motion and mass. In that way, the paradox dissolves into something far more human, the realization that no two journeys ever move through time the same way. So the twins meet again, one lined by memory, the other bright with the freshness of years they never had to spend. They look at each other and see the strange symmetry of existence, the proof that time is soft enough to bend, yet firm enough to never break. And for a moment, they both understand that time travel doesn't belong to myth or machinery. It already lives within the laws that cradle us, waiting quietly in the folds of motion. The traveler has gone to the future and returned, not through dream or magic, but through the simple grace of how the universe keeps its time. Imagine space as a vast ocean, smooth and silent, stretching beyond sight. Normally, we move across its surface, one slow wave at a time, crossing enormous distances that defy comprehension. But what if, instead of sailing the long way around, you could dive straight through, slip beneath the surface, and emerge somewhere else entirely? That is the promise of the wormhole, a tunnel that folds the universe back on itself, connecting places that might be light years apart, or perhaps even moments separated by centuries. The idea began not as science fiction, but as a side effect of Einstein's equations. When two physicists, Einstein and Rosen, examined how gravity bends space-time, they found that under certain conditions, the equations allowed for bridges, shortcuts between two distant regions. They called it an Einstein-Rosen bridge, though it was later given a more evocative name, the wormhole. The name fits. Just as a worm burrows through an apple, emerging on the opposite side without crawling over the surface, a wormhole could pierce through space-time itself. The apple doesn't change, it simply folds differently. If such a tunnel could exist, it would be unlike anything we can imagine. At its center lies a throat, a narrow passage where space and time twist together into something inseparable. On one end, there might be the Milky Way. On the other, a galaxy billions of light years away, or perhaps a completely different universe. Step inside, and your notion of distance becomes meaningless. The stars would smear into ribbons, your sense of direction would vanish, and the familiar flow of time could stretch, reverse, or split entirely. But there's a problem. According to general relativity, wormholes are unstable. The moment they appear, gravity collapses them shut faster than light can pass through. The fabric of space-time, it seems, resists shortcuts. It's as if the universe is designed to protect its own continuity, sealing these tunnels before they can be used. And yet, Physicists have found one possible loophole, something called exotic matter. Exotic matter isn't simply strange, it's hypothetical, a kind of substance that would possess negative energy. Unlike ordinary matter, which pulls and compresses, negative energy would push outward, holding a wormhole's throat open against collapse. Theoretically, it could create a tunnel wide enough for light, or even a spacecraft to pass safely through. We've never seen such matter in bulk, though tiny traces of negative energy may appear briefly in quantum experiments, flickering in and out of existence like static. If we could ever harness it, we might not only bridge vast distances, but alter the very direction of time itself. That's because wormholes, once stabilized, could connect not just places, but moments. If one mouth of a wormhole were moved, accelerated close to the speed of light, or placed near a strong gravitational field, its flow of time would slow relative to the other. When they were brought back together, stepping through might carry you to the past or the future. It's an unsettling possibility. Two doorways existing in the same universe, yet each belonging to a different now. To imagine it, picture two mirrors facing each other in a dark room. Between them stretches an infinite corridor of reflections. A wormhole is like that corridor, except the reflections are real points in space and time. Walk through one, and you might emerge at the other end before you ever left. Every rule of cause and effect would have to bend to accommodate the new geometry. Some physicists believe that the universe forbids this, that quantum effects would destroy any wormhole that allowed backward travel. Others think the universe might permit it, but only under strict conditions, preventing paradoxes through subtle adjustments we don't yet understand. Even so, the mathematics is hauntingly beautiful. Einstein's equations do not demand that wormholes exist, but they quietly allow for them, like hidden doors written into the architecture of reality. Across decades, theorists have drawn maps of possible traversable wormholes, space-time bridges, sustained by exotic fields or cosmic strings. Some even speculate that tiny wormholes could exist at the quantum scale, opening and closing trillions of times a second, stitching together the vacuum beneath everything we see. If that's true, then perhaps the universe is already full of them. Microscopic tunnels connecting every particle, every atom, every heartbeat. Maybe gravity itself is the faint whisper of these connections, the echo of matter communicating through hidden pathways in the dark. And maybe, somewhere among them, a few might stretch far enough for us to notice. The dream of walking through such a tunnel has inspired generations. Science fiction imagines portals between stars, doorways to parallel worlds, or shortcuts through time's corridors. But the deeper truth is quieter, almost spiritual. Wormholes, real or not, remind us that separation is an illusion. The cosmos is not a scattering of isolated islands, but one continuous fabric capable of folding back upon itself. The distance between here and there, between now and then, might not be as permanent as we think. If we ever learn to control these folds to weave tunnels through the geometry of existence, it would mean more than faster travel. It would mean rewriting our relationship with the universe. No longer bound by the long, patient passage of light, we could reach across centuries in a breath. But even if we never build such a bridge, the idea itself is a gift. A reminder that space and time are not barriers, but a single, living surface still waiting to be explored. And perhaps, somewhere far beyond our current understanding, the first wormhole already exists, silent, stable, waiting in the dark. A doorway not only through distance, but through the deepest mystery of all. That time, like space, may one day prove to be something we can step through. Imagine tracing a circle in sand, a perfect loop with no clear beginning or end. Now imagine that loop not on a beach, but in time itself. Every event, every thought, every heartbeat folding neatly back to the one before it. No first sunrise, no final night. Just motion, repeating forever, seamless and self-contained. It sounds like a thought experiment, or a myth whispered by philosophers. But within Einstein's equations, such loops can exist. They're called closed time-like curves, and in their strange geometry, the past and future blur until they become the same. In most of our universe, time feels like an arrow. It moves in one direction, steady and relentless. Ice melts, stars burn, people grow older. But general relativity never promised that this was the only way things could be. Deep within its mathematics lie solutions that twist time into circles instead of lines. One of the first to see it was Kurt Gödel, a quiet mathematician who found that under the right conditions, a universe filled with rotating matter space-time itself could swirl like a whirlpool. Within that swirl, you could leave a point in time, travel along a curve through space, and return to your own past without ever breaking the laws of physics. Gödel's universe was unsettling because it felt so plausible. Nothing magical, no violation of relativity, no exotic matter required, just rotation, pure and simple. It implied that time might be more flexible than we dare admit, capable of looping back upon itself like thread through fabric. If such loops exist, the notion of cause and effect begins to dissolve. The event that triggers something might also be created by it. The line between before and after vanishes, replaced by a dance where both lead and neither begins. Think of a clock ticking in such a place. Its hands sweep forward, yet somehow return to the exact same instant they began. The people inside that loop would live their lives again and again, unaware that they'd done it countless times before. Each moment would feel new, yet it would always end exactly where it started. You could meet someone, speak a word, make a choice, and all of it would already be written into the circle. Nothing would ever truly change, because change itself depends on time flowing forward. In a loop, everything is eternal and unending, caught in the quiet symmetry of repetition. It's a haunting image, an entire civilization trapped within a self-contained timeline, forever reliving the same sequence of events. To those inside, it would seem normal. They'd have memories, plans, hopes, and regrets. But from an outside perspective, if outside even exists, they'd be watching an infinite film reel playing the same story again and again, with no beginning credits and no final scene. Not all loops would feel this clean. Some might fold unevenly, allowing small differences, each cycle tiny variations rippling through the pattern like imperfections in glass. Maybe a thought strays, a decision wavers, and a new version of history emerges before folding back once more. It's here that physics meets philosophy. If every possibility can exist within a self-returning timeline, what does it mean to choose? Are we actors in a script, or co-authors revising it endlessly? Modern physics keeps toying with these questions. Some solutions, like the Tipler cylinder or certain wormhole models, also allow for closed time-like curves, though they require absurd conditions: infinite energy, rotating cosmic strings, or massive structures beyond our ability to imagine. Yet the fact that the math works at all suggests that time might not be as linear as our senses insist. The equations don't forbid loops. They quietly permit them, hidden deep within their logic, as if the universe itself is comfortable with circular causality, even if we are not. If time can loop, then paradoxes become more than stories. They become geometry. A traveler might go back to prevent something that, in doing so, ensures their own need to return. A cause might be born from its own effect. It's less a contradiction than a feedback loop, a pattern sustained by its own existence, like a melody that feeds through an amplifier, stable yet strange, echoing endlessly within its own frame. Some physicists argue that quantum mechanics might prevent such loops from forming, protecting reality from contradictions through something called the chronology protection conjecture. It's as though the universe enforces a kind of cosmic etiquette, no meddling with your own past. But others wonder if these protections are incomplete, that perhaps loops already exist somewhere out of reach, in regions of space-time we'll never see. The cosmos may be large enough to hold every version of time, including the circular ones, and perhaps, in some quiet way, we've already felt the pull of repetition. History itself moves in rhythms. Patterns of rise and fall echo across centuries. Stars are born, shine, and collapse, scattering the elements that will one day light new stars again. Even our thoughts loop. Memories revisited, emotions replayed, lessons relearned. Maybe the seeds of time's circular nature aren't confined to far-off galaxies or exotic physics. Maybe they're woven into the way we already live. If time truly folds back on itself, then everything we do might ripple endlessly forward and backward, resonating through every loop. There would be no first thought, no last breath, only the curve, bending ever inward. And somewhere within that curve, perhaps we've been here before, speaking these same words, wondering the same things, reaching once more for the edge of understanding before the circle closes again, quiet and complete. It begins with a question so simple it feels like a child's riddle. What if you went back in time and stopped your own grandfather from ever meeting your grandmother? If you succeeded, you'd never be born. But if you were never born, how could you have gone back to stop them? This thought experiment, known as the grandfather paradox, is one of those ideas that seems almost playful until you realize it touches the deepest layers of what time, existence, and reality actually mean. It's a knot that can't be untied without changing the shape of the rope itself. In the classic version, the traveler steps into the past, armed with knowledge and intention. They stand in a time that should no longer belong to them. Around them, everything looks familiar, yet reversed cars from another decade. People younger, voices echoing with words that were never meant to be heard twice. They find the man who would one day be their grandfather, living a life untouched by the weight of the future. And then comes the choice, small or monumental, a conversation, a warning, an accident. The paradox doesn't require violence, only interference. Change one thread, and the entire tapestry of history begins to tremble. But physics is stubborn. It doesn't like contradictions, and the laws of causality are the rails that keep the train of the universe running. If an event in the past were changed in a way that prevents the future event that caused it, the result is a logical impossibility, a snake swallowing its own tail. Yet within the mathematics of space-time, the paradox doesn't break the equations. It only challenges our interpretation of them. Some physicists suggest the universe would protect itself from contradiction. Something would intervene, a coincidence, a distraction, a sudden hesitation to make sure events unfold exactly as they must. You might go back in time with the intent to stop your grandfather's marriage, only to find that every action you take inadvertently ensures it happens. A gust of wind closes a door. A missed train puts you in the wrong place. A stranger's kindness changes your plan. The timeline heals itself, preserving the chain of cause and effect like a living organism protecting its core. Others see a different solution. Perhaps you can change the past, but not your past. The moment you interfere, you create a new timeline, a parallel branch where events diverge. In that branch, your grandfather never meets your grandmother, and you never exist. But in your original universe, you always did. You've simply crossed over into another version of reality, leaving your own intact. Every decision, every interference, births a new world. Time travel, then, isn't rewriting the book. It's creating a new edition, bound in the same language, but telling a slightly different story. This idea fits beautifully with the multiverse theory, the notion that infinite universes exist simultaneously, each representing a different outcome of every possible event. Somewhere, a coin you flipped landed on heads instead of tails. Somewhere else, you turned left instead of right, spoke instead of staying silent, lived instead of dying. If time travel creates branches rather than loops, then paradoxes dissolve like mist. You could change the past, but only by stepping sideways into another version of existence. The act of interference doesn't destroy the timeline, it multiplies it. Still, there's something haunting about this view. If every decision births another reality, then every regret, every choice not made, also exists somewhere. There is a universe where you became the person you once dreamed of being, another where you never left home, another where you never asked the question that led you. Here, infinity blooms quietly around us, unseen but complete. Time travel wouldn't create chaos, it would reveal how much of it already exists. And yet, even in the branching model, the paradox lingers in the heart. Could you meet yourself in another world? Could you look into the eyes of someone who shares your memories but lives a different truth? Theoretically, yes. Practically, it might be unbearable. Two versions of the same person cannot coexist without redefining identity itself. If you met the you who never time traveled, would they recognize you as kin or as a disruption? In that moment, you wouldn't just be a traveler between times. You'd be a fracture in the mirror of reality, a reminder that existence isn't singular. Quantum mechanics offers another whisper of explanation. In that strange realm, particles can exist in multiple states at once until they are observed. The universe, too, might hold all possibilities simultaneously, each timeline superimposed upon the others. Traveling through time might simply mean shifting which version of the universe you're tuned into, like changing a frequency on a cosmic radio. You wouldn't rewrite the past, you'd move to a station where the song was already different. But perhaps the most elegant solution is the one that requires no branching, no intervention, no contradiction at all. Maybe you can travel to the past, and everything you do there is already part of history. You were always meant to go back. Your actions, no matter how deliberate, were already woven into the pattern that led to your own existence. The universe contains its own consistency, perfectly self-correcting. In that view, there are no paradoxes, only loops too complex for us to see. The grandfather paradox endures because it reflects our most human impulse to wonder if we could have done it differently, if time would forgive a single altered choice. It tempts us with the idea of mastery over regret. But the deeper we follow it, the more it shows us that time is not something we can control. It's something we participate in, something that includes us as part of its design. The past, the present, and the future are not enemies vying for dominance. They're companions in the same circle, whispering the same story from different points along its edge. And maybe that's the quiet answer. You cannot erase yourself, because you are already written into every version of the universe that could ever exist. Change the past, and you'll only find yourself again waiting, inevitable, in whatever shape time allows. If time ever reveals its secrets, it will not be through roaring machines or glowing portals, but through the smallest things imaginable. Not galaxies, not atoms, but the trembling probabilities that live beneath them, particles so delicate that even looking at them changes what they are. This is the quantum world, a place where cause and effect blur, where the present can influence the past, and where time itself behaves less like a line and more like a mist. If there are time machines anywhere in the universe, they already exist here, hidden in the restless shimmer of the subatomic. At the heart of this strange reality is superposition, the idea that a particle can exist in multiple states at once, here and there, now and later, on and off until it is observed. It isn't indecisive, it's obedient to the rules of possibility. A photon traveling through space doesn't choose a single path. It explores every path simultaneously, each one whispering its own probability of being real. When it reaches its destination, only one version survives, collapsing into what we call an outcome. But the collapse doesn't just decide the present, it rewrites the past. The universe recalculates its story so that everything leading up to that moment always made sense. It's as though reality edits its own history in real time, ensuring no contradictions survive. This retroactive adjustment is called retrocausality, the idea that effects can ripple backward, shaping their own causes. In experiments, Physicists have shown that decisions made in the present can change the behavior of particles in the past. In the delayed choice experiment, photons sent through a beam splitter seem to decide whether they behaved as waves or particles only after the measurement has been made. The universe waits for us to make up our minds before finalizing what happened. The arrow of time, so strict in our daily lives, softens into a loop at the quantum scale. Entanglement takes the mystery even further. Two particles born together remain connected no matter how far they drift apart. Touch one, and the other reacts instantly, faster than any signal could travel. Einstein called it spooky action at a distance, unable to accept that the universe could coordinate itself faster than light. But it does. Entangled particles share information outside the normal limits of time and space, as if both are merely local illusions, shadows cast by something deeper. Measure one particle today, and you define the state of its partner, even if that partner is light years away, or even if it existed in the past. Entanglement doesn't care about distance or sequence. It simply is. If communication can happen beyond the speed of light, it raises a quiet, dizzying question. Could information travel backward through time, not through paradox or machinery, but through the natural behavior of quantum systems themselves? In certain interpretations, entangled particles act as messengers across timelines, transmitting correlations that stretch both forward and backward. It's not that a signal is sent, exactly, but that the universe maintains coherence across all directions of time. The outcome of a measurement might depend on something that hasn't yet happened, or something that already has. The future and the past, it seems, negotiate continuously to agree on the present. Quantum computers might be the first technology to truly play in this arena. Unlike classical computers, which process information linearly, quantum machines use qubits units that can exist in many states simultaneously. This allows them to perform countless calculations at once, exploring multiple timelines of possibility before collapsing into an answer. Some physicists describe quantum computation as a kind of controlled time travel within mathematics. The computer sends information through all possible futures, retrieves what works, and delivers the result as if the calculation occurred instantaneously. It doesn't so much solve a problem as consult every version of reality until one agrees. This concept, while breathtaking, also hints at something more profound, that information might be the fundamental fabric of existence. The universe, at its core, could be less about matter and energy than about the processing of possibilities. Every particle interaction, every fluctuation, could be a negotiation of timelines, a constant exchange between what could be and what is. From that perspective, time travel doesn't require movement through space. It requires access to information from another moment, and the quantum world may already be doing it quietly, endlessly, beneath our perception. There's a strange kind of peace in that thought. Perhaps the past is not gone, nor the future distant. Perhaps they are both here, layered like translucent pages, and the universe reads them all at once. When we observe, we choose one version of the text to focus on, collapsing infinite drafts into a single story we can understand. But the others still exist, unread, unwitnessed, humming in the background. If we ever learn to truly harness quantum time, it won't look like a doorway or a tunnel. It will look like understanding. It will look like stillness, the realization that every particle is already both cause and effect, that every moment folds softly into every other. The quantum world doesn't break the rules of time. It reveals that time was never linear to begin with. So maybe one day, when our technology grows subtle enough, we won't need to build machines to visit the past. We'll only need to listen to the quiet pulse of entangled particles, to the shimmer of superposition, to the murmur of a universe already speaking to itself across centuries. In their language of probabilities and echoes, we might finally hear the truth, that time is not a road we travel, but a song we're still learning to hear from every direction at once. If time could be seen instead of felt, it wouldn't look like a line stretching endlessly in both directions. It would look more like a sculpture, solid, complete, existing all at once. Every event, every heartbeat, every breath you've ever taken would be frozen within it, layered like minerals pressed together through eternity. You wouldn't stand at one end looking forward or backward. You would simply exist within it, one point among infinite others. This is the block universe, the unsettling idea that the past, present, and future are not separate realms at all, but coordinates on a single, unchanging map of reality. In this view, the universe doesn't unfold or progress, it simply is. Every moment that has ever happened and will ever happen already exists within the grand structure of space-time. The birth of stars, the fall of empires, the quiet sip of your morning coffee, they're all preserved, side by side, immutable. Time doesn't flow through the block any more than height flows through a mountain. What we call the present is just the slice of that mountain our consciousness happens to be standing in. To us, it feels like motion, but the landscape itself never moves. Einstein once wrote that the distinction between past, present, and future is only a stubbornly persistent illusion. In his equations, time is a dimension, woven together with space. Move through one, and you inevitably move through the other. There is no universal now, no single clock ticking for everyone. Each observer carries their own timeline, curved and stretched by gravity and motion. When you begin to see it this way, the arrow of time loses its authority. The universe becomes a complete work of art, timeless, finished, and perfect in its totality. This doesn't mean our experience of time is meaningless. It means that consciousness itself may be the traveler. Imagine a flashlight moving slowly through a film reel. The light illuminates one frame at a time, bringing it to life, even though every frame already exists. You are that beam of awareness, sweeping through the cosmic movie frame by frame, creating the illusion of flow. Each instant of your life, the laughter of childhood, the heartbreaks, the moments of quiet wonder, is permanently etched into the reel. You never lose them, you simply move past them. To stand inside this vision of reality is to understand that nothing is truly gone. The people you miss, the moments you regret, the days you thought slipped away, they still exist, anchored in their place on the timeline. Somewhere, right now, the version of you reading this has not yet been born. Somewhere else, you've already lived 1,000 lifetimes. From the block's perspective, they are equally real, equally alive, shimmering forever within the same vast geometry. The universe is not a story being told, it's a story that has always been. This raises a haunting question. If everything already exists, what does it mean to choose? If the future is as fixed as the past, are we simply following a path carved long ago, mistaking inevitability for freedom? Some philosophers call this eternalism, and it paints a picture of existence that is both comforting and cruel. Comforting because nothing is lost, cruel because nothing can be changed. Yet, even that distinction might miss the point. In a block universe, change is not erased, it's part of the structure. Every transformation, every decision is already built into the whole. Free will may still exist, but not as rewriting. Instead, it's the awareness of what is already written. Quantum physics adds its own strange texture to this idea. At the smallest scales, events don't occur in strict order. Causes and effects mingle, probabilities shimmer, and particles seem to experience past and future simultaneously. If reality behaves that way at its foundations, perhaps the block is not static after all, but dynamic in a way we can't yet perceive. The map might be fixed, but consciousness may be what gives it movement, a traveler sweeping light through the shadows of eternity, painting the illusion of sequence upon what is otherwise timeless. It's a humbling perspective, When you pause to breathe, to notice the faint rhythm of your heart, realize that this moment, this exact intersection of atoms and thoughts, is immortal. It's there forever, alongside every moment you've ever known or will know. You're not drifting through time so much as exploring a structure that was always complete. You're a traveler crossing your own landscape, touching each moment once before moving to the next, but never truly leaving any behind. Perhaps that's why nostalgia feels like a kind of homesickness. Somewhere within the block, your childhood still plays out in golden light. Somewhere else, your future self is looking back, remembering this instant with the same ache. The you of then and the you of now are neighbors in space-time, unaware of how close they truly are. Maybe when you dream, your consciousness slips for a moment, touching another part of the map, past or future, and returns with the faint echo of having been elsewhere. The block universe suggests that time doesn't pass. We do. We move through it like travelers crossing a frozen sea, leaving trails that are already there. Every laugh, every loss, every second you thought was fleeting is still written into the fabric of reality, waiting patiently for the light of your awareness to pass through once more. And maybe, in that infinite stillness, the truth is gentler than it sounds. Nothing ever really ends. It just waits, quietly, forever, in its place in the block. Part of a story that was never meant to move, only to be. If light is the fastest messenger in the universe, then tachyons are the ghosts that outrun it. They exist, if they exist at all, in a realm just beyond the boundary of the possible, a place where cause and effect trade places, and where the future is not waiting to arrive but already whispering backward into the present. No one has ever seen a tachyon. They are born in equations, not laboratories. Yet the idea of them refuses to die, because hidden inside the math is something daring, a suggestion that faster-than-light motion might not just be movement through space, but a kind of travel through time itself. Einstein's theory of relativity gives light a special privilege. It is the universe's speed limit, the one thing that all observers, no matter how fast they move, will measure the same way. As you approach that limit, time slows, mass increases, and the energy required to go faster climbs toward infinity. It's as if the universe itself bars the door, protecting causality from being unraveled. But in 1967, a physicist named Gerald Feinberg asked a question that tilted the table slightly. What if there were particles that didn't need to accelerate up to light speed because they were born beyond it? Instead of slowing down as they gained energy, they would speed up. Instead of existing in our domain of space and time, they would live in a mirror universe where the rules were inverted. They would be perpetual travelers, never able to slow to light speed any more than we could speed up to it. From our point of view, such particles would appear bizarre. Their mass would be imaginary, their energy defined by complex numbers that don't quite fit into physical intuition. But the mathematics is consistent, and in that consistency lies an unsettling truth. Tachyons, if real, could move backward through time. A signal sent from one might arrive before it was transmitted. A cause might echo after its effect. To us, their existence would look like a whisper from the future, an influence that precedes its own source. Imagine, for a moment, what it would be like to live as one of them. You would never know stillness. The universe would not expand away from you. It would collapse toward you, folding all of space into an approaching horizon. The flow of time would invert. You would watch history unravel backward, stars undying, planets unforming, civilizations undiscovering fire. The Big Bang would not lie in your past, but in your future, a bright wall of birth rushing to meet you. Every motion would be reversed, every cause rewritten. To you, we would seem impossibly slow, like statues caught mid-thought in amber, frozen by the drag of light-speed time. If such beings or particles exist, they would see our world in reverse, and from their perspective, it would be we who move backward through time. Communication between the two realms would be dangerous, perhaps impossible, because information sent from one side could create paradoxes in the other. Yet, paradox or not, there are hints, strange anomalies in quantum experiments that make some physicists wonder whether tachyon-like effects already flicker at the edges of reality. In certain observations, particles behave as though they've been informed of future measurements, adjusting their behavior before the experimenters make a choice. These results may not require tachyons, but they echo the same theme. Nature does not always wait for us to decide what has happened. The idea of faster-than-light messengers carries deep consequences. If we could harness them, even briefly, communication across light years would become instant. A message from Earth to a distant star could arrive before it was even sent, creating a chain of self-consistent loops that challenge every definition of cause and consequence. Some theorists suggest the universe might already use such a system to balance itself subatomic transactions that keep space-time coherent by sending tiny ripples of information backward and forward simultaneously. What we experience as stability may, in truth, be the result of endless negotiation between past and future, mediated by messengers we cannot see. There is a kind of poetry in that. If light is the storyteller of the cosmos, illuminating what has already occurred, tachyons would be its editors, moving quietly through the manuscript to ensure the ending fits the beginning. Perhaps the symmetry we see in the laws of nature, the way equations work just as well forward as backward, isn't coincidence at all. Perhaps it's the signature of a deeper communication, one that transcends the simple flow of time. And yet, like all dreams that travel too fast, tachyons may remain forever unreachable. They could exist just outside our frame of reference, woven into the background of reality in ways we can never directly measure. Or they may not exist at all, only a mathematical mirage, showing us what would happen if the cosmic speed limit were ever broken. But even as a mirage, they offer a glimpse into the possible. A universe that doesn't march forward but resonates, every moment echoing both ahead and behind. When you look up at the night sky, every photon that reaches your eyes is a message from the past, its journey measured in years or millennia. But what if, somewhere deep beneath that glow, there are other messengers traveling the opposite direction, arriving from futures not yet lived, whispering into the weave of space-time the instructions that make tomorrow possible? Perhaps we are already shaped by them, our present molded by ripples that originate in moments yet to come. The tachyon, real or not, remains a symbol of the universe's most intoxicating possibility, that time might not be a wall, but a window, and that every instant, no matter how small, could be in quiet conversation with its own reflection, reaching endlessly both forward and back. In ordinary crystals, beauty is carved into space. Their atoms stand in neat formation, repeating in perfect symmetry, like an infinite dance frozen in mid-step. Diamonds, snowflakes, and salt all share this quiet order, each a monument to structure and stillness. But in 2012, a physicist named Frank Wilczek imagined something even stranger, a kind of crystal that wouldn't just repeat in space, but in time. Instead of stillness, it would shimmer with perpetual motion, endlessly cycling between states, never settling, never tiring, a pattern that didn't just exist, but lived. At first, the idea sounded impossible. The laws of physics insist that systems eventually settle into equilibrium, that motion fades, and that energy disperses. Perpetual motion has always been the forbidden dream of science, a mirage on the horizon of every equation. Yet Wilczek's idea wasn't about violating conservation of energy. It was about symmetry. He asked, what if time itself could have structure the way space does? What if, at the smallest scales, there could exist a rhythm that repeats forever, pulsing through the universe even when everything else grows still? Years later, experiments proved that such systems could exist. In ultra-cold labs, physicists began trapping ions in electromagnetic fields and pulsing them with lasers. To their astonishment, The atoms began oscillating, flipping between configurations in a perfect, repeating cycle without consuming energy or slowing down. It was as if the atoms had discovered their own heartbeat, one that ticked eternally, without decay. These became known as time crystals, and their discovery sent a ripple through physics so profound it bordered on metaphysical. For the first time, we found objects that move forever without losing energy, not because they defy entropy, but because they live outside its jurisdiction. To understand them, imagine a pendulum that never stops. In our world, every swing costs energy. Friction steals a little with each motion, until eventually the pendulum comes to rest. But a time crystal doesn't pay that price. Its atoms switch states in a loop that doesn't consume fuel or release heat. It's not perpetual motion in the mechanical sense, it's perpetual structure, a repeating pattern in the fabric of time itself. The system as a whole doesn't gain or lose energy, yet internally, it moves in a rhythm that never fades. It's a paradox made real. Motion without momentum, change without cost. This discovery hints at something profound about the nature of time. We've always imagined time as a one-way flow, a current carrying us downstream from birth to death, from creation to decay. But time crystals suggest another truth, that time, too, might be granular, capable of pattern and repetition, capable of standing still and moving all at once. They show us that even in the quietest void, order can emerge from chaos. Structure can arise in the unseen dimension that governs everything. In a way, time crystals are the universe's way of humming to itself. Each oscillation is like a verse in an endless song, repeating without fatigue, looping through eternity at the smallest scale. If you could shrink yourself down and stand among those atoms, you wouldn't find motion as we understand it. You'd find rhythm. It wouldn't feel like a ticking clock, but like a vibration woven into existence, a breath that never ends. And yet, time crystals don't violate the flow of time, they coexist with it, carving tiny pockets of temporal order into the background chaos. Their repetition is stable not because they escape time, but because they embrace its hidden symmetries. For physicists, they represent a new phase of matter, one that forces us to rethink what it means for something to exist in time rather than merely endure through it. For philosophers, they whisper something more poetic, that eternity might not be an endless stretch of duration, but a perfect repetition. Some researchers now wonder whether time crystals could be used to build quantum computers more stable than any before them. Quantum systems are fragile. They collapse under the slightest disturbance. But a time crystal, locked into its unending cycle, could preserve information indefinitely. It could serve as a kind of heartbeat for quantum logic, a clock that never falters. In that sense, these shimmering patterns of motion could one day power machines that think and remember beyond the lifespan of any ordinary system. But perhaps their greatest gift is the metaphor they offer. In a universe defined by decay, they are proof that not all motion ends. They are the quiet defiance of entropy, the smallest rebellion against time's forward march. Their dance reminds us that movement and stillness are not opposites. They are reflections of the same truth. Even as galaxies drift apart and stars cool into silence, somewhere in the quantum dark, tiny systems continue to oscillate forever, keeping time not with seconds or minutes, but with eternity itself. If you listen closely to that idea, there's something deeply human in it. We, too, repeat. Our hearts beat, our lungs cycle, our thoughts return in patterns. Our lives move in loops, seasons, memories, generations, each iteration slightly different but never fully gone. Perhaps time crystals are not so alien after all. Perhaps they are mirrors of us, revealing that even in a universe obsessed with endings, there are still places where the story refuses to stop, where time itself hums, softly, endlessly, in the dark. Every morning, the sun rises, shadows retreat, heat seeps into air, and the world wakes again. It feels so natural that we rarely question why time itself only seems to move in one direction, why the past hardens into memory while the future remains fluid and undefined. Yet beneath every tick of the clock lies one of the greatest mysteries in physics. Why time has an arrow at all? The universe could have been timeless, its events symmetrical, each moment reversible like a film that can play forward or backward. But that isn't what we see. The arrow points one way, always. And the reason may lie not in the ticking of clocks, but in the quiet hunger of entropy. Entropy is the measure of disorder, a simple word that hides a deep truth about the cosmos. It's what happens when energy spreads, when structure dissolves, when patterns fray into randomness. A cup shatters, never the other way around. Smoke disperses from a candle, but never curls back into the wick. Ice melts into water, never the reverse unless energy is deliberately spent to restore order. Entropy always increases, creeping forward like a tide that cannot be turned. It's not malevolent, it's simply the natural direction of things. At the dawn of the universe, things were different. The cosmos began in an astonishing state of order, a hot, dense sea of particles perfectly arranged, like a deck of cards stacked in sequence. Over time, that order began to unravel. Matter clumped into galaxies, stars ignited and burned, and energy spread ever outward. Each event was another shuffle of the cosmic deck, another step toward disorder. That steady drift toward chaos defines the arrow of time. We move forward not because the future pulls us, but because entropy pushes us from behind. Every breath you take is part of this process. Inside your cells, energy flows from high to low. Heat dissipates, molecules rearrange. Life itself is an island of temporary order, sustained against entropy's tide, a fragile structure maintained by constant expenditure. You burn food, break down energy, release heat, and in doing so, you push the universe slightly further along its path of disorder. Even when you rest, entropy hums quietly beneath your skin, patient and absolute. And yet, this slow unspooling of order is what makes experience possible. Memory, for instance, depends on the arrow of time. When you recall a moment, your brain stores and retrieves information through irreversible processes, chemical changes that can't simply run backward. If time reversed, memory itself would vanish. You wouldn't remember the past because it wouldn't exist as past at all. The arrow of time doesn't just govern physics, it gives rise to consciousness, to the sense of sequence that makes existence feel like a story. Thermodynamics tells us that, left alone, all systems drift toward equilibrium, a uniform state where no energy can be harnessed, no work can be done. This is the universe's ultimate fate, heat death. It's not fire or explosion, but silence. Every star will fade, every difference in temperature will even out, and the cosmos will become a vast, dark, calm, a place without contrast, without motion, without time as we know it. When entropy reaches its maximum, there will be nothing left to change, and without change, there is no before or after. Time's arrow will dissolve into stillness. But what if, somehow, entropy could reverse? If disorder began to decrease, the film of reality would start to run backward. Stars would reassemble from their ashes. Collapsed structures would rebuild. Heat would flow from cold to hot, defying every instinct of thermodynamics. The future would look like restoration instead of decay. From our perspective, everything would seem wrong: coffee unmixing from cream, thunder returning to clouds, the dead awakening into life. Yet to the inhabitants of that reversed world, nothing would seem strange at all. Their arrow of time would simply point the other way, and they would remember what to us would be the future. Some physicists suggest that on the grandest scales, the universe might already contain regions where time flows in reverse. If the cosmos expands forever in one direction, perhaps on the other side of the Big Bang, it expands backward, forming a mirror universe where entropy increases the opposite way. From our perspective, their time would flow in reverse. From theirs, ours would. Both universes would obey the same laws. Both would move toward greater disorder, but in opposite temporal directions, balanced perfectly across the divide. It's humbling to realize that the arrow of time, the one constant of our existence, may be little more than a local feature of entropy's drift. We ride the wave of decay, mistaking it for motion. The universe isn't marching toward an end. It's simply evening itself out, spreading its energy thin across the infinite. What we call the future is just the direction in which things crumble most efficiently. And yet, within that grand unraveling, something astonishing happens. Complexity blooms. Stars die, but their deaths scatter elements that give birth to life. Entropy increases, but life uses that increase to create meaning, structure, and consciousness. We are made of decay and persistence in equal measure. Our existence is the echo of the universe's slow fall into disorder. A brief pause in the flow, a moment of awareness flickering against the dark. Time's arrow, then, is not our enemy. It is the motion that allows us to exist at all. Without it, there would be no change, no evolution, no memory, no story to tell. The universe may prefer disorder, but in its endless expansion toward chaos, it has given rise to something remarkable. Beings who can see it happening, who can love within it, who can look at the flow of time and whisper, however, briefly, that they were here as it passed. There are moments in science that feel like echoes, subtle, haunting repetitions that don't fit within the expected rhythm of cause and effect. A flash of light that arrives before it should, a particle that reacts to a choice not yet made, a heartbeat that anticipates what's coming before the mind does. These are not the fantasies of fiction, but data fleeting, controversial, and deeply unsettling. Across physics, psychology, and neuroscience, there are hints that the future might already be whispering backward through the noise of the present, sending faint ripples that we sometimes mistake for intuition, coincidence, or déjà vu. It began, as many mysteries do, in the quantum realm, the only stage where time seems to hesitate before choosing a direction. In the delayed choice experiments of the 20th century, photons were sent through a maze of mirrors and detectors, their behavior depending on whether they were measured as particles or waves. But here's the strangeness. Scientists could decide how to measure the photon after it had already passed through the experiment. And somehow, the photon behaved as though it knew in advance which choice would be made. The outcome in the present appeared to depend on an event in the future. Reality, it seemed, was adjusting itself retroactively to make sense of the final result. In another version, called the quantum eraser, the same effect unfolded more dramatically. When scientists chose to erase or keep information about a particle's path after it had already been detected, the results changed accordingly, as if the act of observation reached backward in time, rewriting the past. No messages were sent faster than light, no paradoxes arose, and yet something fundamental cracked in our understanding of sequence. The universe was not behaving like a line of dominoes falling neatly one after another. It was behaving like a web, tugged in multiple directions at once, the future and past braided tightly together. Some physicists shrug and say, this is simply how quantum mechanics works, that causality is not violated, only misunderstood. Others dare to wonder if these results hint at a deeper connection between moments, a kind of dialogue across time. If so, the implications are staggering. It would mean that every instant is not isolated but entangled, each decision vibrating faintly across both directions of the timeline. When you make a choice, its echo might travel forward and backward, shaping not only what comes next, but what came before. Outside the laboratory, stranger whispers emerge. In the late 20th century, psychologist Daryl Bem conducted experiments suggesting that human beings might unconsciously sense the future. Participants were shown images, some neutral, some emotionally charged while their physiological responses were measured. Remarkably, their bodies often reacted moments before the image appeared. Heart rates quickened, skin conductivity rose, pupils dilated, as though the nervous system was already preparing for what the eyes had yet to see. Critics argued the results were statistical noise, but the pattern repeated too persistently to ignore. The future, in these studies, didn't shout. It murmured softly, just beneath awareness. Other experiments with random number generators hinted at something similar. Machines producing purely unpredictable sequences appeared to drift slightly from randomness during major global events, earthquakes, tragedies, celebrations, as if human emotion or collective attention rippled backward in time, subtly influencing the data before the event occurred. To some, it was coincidence. To others, it was the faint heartbeat of a hidden connection between consciousness and causality. These findings remain controversial, and yet they speak to something primal in us, the feeling that we sometimes sense things before they happen. The moment before a loved one calls, the instant before an accident when the body moves without thought. Science calls it pattern recognition, instinct, probability. But what if it's something deeper? What if consciousness itself is not bound strictly to the present, but stretches across time like a thread, tugging faintly at what lies ahead? Perhaps the future is not waiting for us to arrive. Perhaps it's already here, woven into the same tapestry as the past, its signals faint but constant. In quantum theory, time is not a single flowing current, but a network of correlations where knowing something now can reveal something that has not yet happened. The universe may not distinguish between before and after the way we do. To it, every moment simply exists, interlinked, complete. We are the ones who perceive the sequence, who feel the current as motion rather than structure. If the future truly echoes into the present, it might not do so with clear words or visions, but through subtler means, probabilities shifting, impulses arising, decisions leaning ever so slightly toward inevitability. A coin flip today might already carry the faint memory of how it will land. A choice made tomorrow might ripple backward into the heartbeat you feel now. There's a strange comfort in the idea. It suggests that time is not a wall dividing what was from what will be, but a mirror reflecting both directions at once. The future could be less a destination and more a partner in conversation, shaping us as we move toward it. And maybe that's why déjà vu feels so uncanny, not because it's a glitch, but because for a brief moment, we catch the echo of that conversation. In the end, the question isn't whether the future can speak, it's whether we've learned to listen. Perhaps the whisper is always there, buried beneath the static of ordinary experience. The tick of a clock, the flicker of a neuron, the shimmer of a photon changing its mind. And in those fleeting instants when the noise quiets and the pattern emerges, we glimpse something extraordinary, not prediction, not fate, but the faint, luminous recognition that time itself might be alive, reaching out to touch us from both directions at once. Imagine standing at a crossroads where every possible path splinters outward, not one or two, but infinite. Each choice you make, each breath, each flicker of thought sends the universe branching into new directions, forming countless realities that coexist side by side. Somewhere, you turned left instead of right. Somewhere, you stayed instead of leaving. Somewhere, you never asked the question that led you here. This is the multiverse, not a theory of other worlds far away, but of other versions of this one, layered invisibly on top of each other, each one as real as the next. The idea was born not from fantasy, but from necessity. Quantum mechanics, with all its brilliance and confusion, forced physicists to confront a strange truth. Particles don't follow single outcomes. They exist in superpositions, exploring every possibility until observation collapses them into one. But what if that collapse never happens? What if, instead, Every possible outcome simply splits reality into parallel threads, each continuing on its own trajectory. Hugh Everett proposed this in the 1950 seconds, and though it sounded heretical at first, it elegantly solved one of physics' most perplexing problems. Instead of choosing a single version of events, the universe allows them all. In this view, paradoxes evaporate. Kill your past self in one branch, and that contradiction doesn't ripple backward. It simply creates a new world where that outcome becomes true. The old one continues untouched. Time travel, in such a cosmos, becomes less about rewriting the past and more about switching tracks within an infinite web of histories. Every alteration, every decision, every accident spawns its own universe, and together they form a vast safety net against the collapse of logic. No paradoxes, no erasures, only expansion. It's a dizzying thought that the universe could be so generous with possibility. It means that somewhere, there's a version of you who chose differently, the job you didn't take, the person you never met, the risk you turned away from. Somewhere, that version is living out the consequences of that path, thinking of you perhaps as the shadow of an unmade life. And maybe, in turn, you are someone else's branch, someone who wonders what became of the version of them that never walked this way. If you could step outside the multiverse and look upon it whole, you would see not a linear chain of events, but a shimmering structure, like coral, blooming endlessly in all directions. Each branch begins as a point of uncertainty, a moment of quantum indifference, and then blossoms into its own coherent world. Every possibility that can exist does exist. Every outcome that could happen does happen. The future is not waiting to be written. It is already written in every form imaginable, playing out across dimensions beyond counting. At first, it feels like chaos. If everything happens, what matters? If every version of you lives somewhere, is choice still meaningful? But the beauty of the multiverse lies not in its abundance, but in its intimacy. You are bound to your branch, to your specific thread of reality, by the accumulation of every decision and coincidence that shaped you. The other versions may exist, but they are unreachable, ghostly echoes of your own potential. The knowledge that they're out there doesn't cheapen this life, it deepens it. Every choice still matters because it defines the version of reality you inhabit. Quantum physics may have birthed the multiverse, but its logic extends far beyond the lab. In cosmology, inflation theory suggests that new universes may constantly bud off from old ones, infinite bubbles expanding within an eternal foam of creation. Each bubble carries its own laws of physics, its own flow of time. In one, gravity might be weaker. In another, light might bend differently. And within some of them, perhaps beings like us look up at their own skies and wonder too, whether their world is singular or shared. The multiverse also offers a strange comfort to the riddle of time. If every possible timeline exists, then the past never truly ends. It continues elsewhere, alive in parallel. The moment you call yesterday doesn't vanish. It diverges. In one branch, you made the choice that led here. In another, that moment continues unfolding, untouched by your departure, like a record playing eternally in another room. The past isn't gone, it's just happening somewhere else. And so, paradox becomes illusion. You cannot break causality because causality is too vast to break. Every contradictory event finds a home in its own universe. Every impossible situation becomes possible simply by shifting where it occurs. Time travel, free will, destiny, all of them coexist peacefully in the infinite sprawl of creation. The multiverse is not chaos, it is balance through abundance. There's something poetic in the thought that existence itself might prefer branching over ending. It suggests that the universe values continuity, that no idea, no action, no spark of energy is ever truly lost. It simply migrates, finding new expression elsewhere. The boundaries between life and possibility blur until they are indistinguishable. Even death, perhaps, is not an ending but a change of perspective, a transition from one branch to another, unseen but adjacent. When you look up at the stars, you are seeing not just the light of distant suns, but the reflection of an idea that reality itself is more generous than we can imagine. Somewhere, beneath layers of unseen possibility, versions of you are looking back, each living, breathing, wondering, within their own perfectly valid slice of the infinite. And maybe that is the universe's quietest mercy, that nothing, not even time, ever truly runs out. It just keeps branching, forever and ever, like light scattering through a prism, each color its own world, each shimmer its own eternity. Out in the dark, beyond the spiral arms of our galaxy, there are clocks unlike any other's dead stars that spin with a precision no machine could match. These are pulsars, the remnants of exploded suns, their matter crushed into spheres only a few miles wide but heavier than entire constellations. As they rotate, beams of radiation sweep across space like cosmic lighthouses, flashing with metronomic accuracy. To astronomers, they are timekeepers of the universe, yet even their rhythm reveals a strange truth. Time itself bends and stretches in their presence. Near a pulsar, gravity distorts seconds into uneven intervals, dragging light into curves and slowing the pulse of existence. To those who watch from afar, their signals arrive delayed or doubled, sometimes bending around unseen masses in space, echoing twice across the same moment. Nature, it seems, is already playing with time's fabric, folding it subtly into shapes we're only beginning to recognize. When we peer deeper beyond the stars, into the subatomic, the distortions become even more haunting. In quantum mechanics, particles don't always move from one place to another in the way we expect. Sometimes they vanish and reappear, skipping across barriers as if space and time were optional. This phenomenon, called quantum tunneling, defies every classical rule. A particle trapped on one side of an energy wall should never cross without enough momentum to climb it. And yet, it does. It simply appears on the other side, as if it had always been there. What's more, experiments suggest it may complete this impossible journey faster than light could travel, the same distance, implying that part of the process occurs outside the normal flow of time. It's here that nature begins to whisper something truly strange. When scientists measure tunneling precisely, they find that the particle sometimes seems to arrive before it has even started its journey. Cause and effect blur. The signal of arrival can precede the moment of departure by infinitesimal fractions of a second. To human senses, it's imperceptible, but to the equations, it's undeniable. The universe is allowing events to cheat chronology, to flicker briefly out of order before the grand balance restores itself. No paradoxes arise, no ruptures in logic, only the faint shimmer of time being less strict than we assumed. Similar echoes appear in the phenomenon of quantum entanglement, where two particles born together remain connected no matter how far apart they drift. Change one, and the other responds instantly, as though distance and time have no meaning at all. To an outside observer, it looks as if the reaction occurs faster than light, or perhaps before the cause has even taken place. But within the quantum fabric, both events are part of a single, timeless interaction, unrolling simultaneously in ways we can only describe, not imagine. Even in the larger world, hints of time distortion emerge in quiet, natural ways. The immense gravity near black holes slows time to a crawl, so that an observer orbiting their event horizon might watch the universe outside race ahead by centuries. In deep cosmic voids, where gravity is weaker, time moves faster. The universe is not one uniform river, but a collection of streams flowing at different speeds, each bending around mass and energy. Every galaxy, every planet, every human heartbeat experiences its own tempo of time. We share the illusion of simultaneity only because our senses are bound to the same narrow slice of it. Closer to home, Biological systems mirror these distortions in miniature. Some migratory birds navigate by sensing the quantum spin of particles affected by Earth's magnetic field, a process that may rely on entangled reactions occurring beyond linear time. Photosynthesis, too, depends on particles finding the most efficient path through complex molecules, seemingly sampling every route simultaneously before deciding which occurred. In the microscopic world, the arrow of time does not march in lockstep. It flutters like a flag caught in shifting wind. Physicists once believed these effects were too small to matter, confined to the quantum scale. But the more we study them, the more they seem to ripple upward, shaping the very structure of reality. The universe, at every level, appears to negotiate time rather than obey it. Pulsars stretch it, black holes imprison it, quantum particles sidestep it entirely. The laws we take for granted, the order of before and after, the linear path of motion, are local customs, not universal decrees. Perhaps that's why we sometimes feel that time misbehaves even in our ordinary lives. A moment of danger lasts forever. A year of peace vanishes in an instant. Memory, emotion, and perception bend the arrow of time into loops and spirals. The brain is its own pulsar, its own gravitational field, stretching moments with attention, collapsing them with indifference. Even our thoughts may echo backward, influencing feelings before reason catches up. Time, as we experience it, may be just another form of gravity, something we carry within us, bending the world to fit our motion through it. If we listen closely to these natural experiments, the pulsar's heartbeat, the quantum particle's leap, the tunneling electron's trick, we begin to see that the universe does not treat time as a one-way road. It treats it as a landscape, pliable and rich, full of shortcuts and detours, folds and reflections. Every flicker of light, every wave of energy, every living system participates in this quiet distortion. Perhaps time travel isn't a future technology waiting to be invented, but a language nature already speaks fluently. It's there in the way particles anticipate, in the way space bends seconds into years, in the way life adapts to rhythms that defy our clocks. And maybe, in moments of intuition or awe, when time seems to pause or stretch or double back on itself, what we're really feeling is the echo of that deeper truth that the universe has never been content to move only forward, and that every heartbeat, every pulse of light, is already a journey through the folds of time. Close your eyes, and you can leave the present. Within a heartbeat, you're no longer here, but somewhere else, back in a childhood room. The light different, the air heavier, the sound of someone's voice just as it was. Or you leap forward into a future that doesn't yet exist, imagining a place, a face, a possibility. No machine hums, no portal opens, yet you have traveled across time. The brain does this so effortlessly that we mistake it for thought, but it is something deeper, a kind of temporal alchemy, a folding of moments that lets us live far beyond the narrow instant of now. Neuroscientists call it mental time travel, the uniquely human ability to re-experience the past and pre-experience the future. It relies on the same networks that light up when we daydream, drift, or imagine the brain's default mode network, a constellation of regions that hum quietly when the mind is at rest. Far from idle, this network is constantly stitching together the tapestry of who we are, recalling details, projecting outcomes, simulating versions of ourselves that don't yet exist. When it activates, the present loosens its grip, and the boundaries of time dissolve. Inside this network, memory and imagination blur until they become indistinguishable. The same neurons that fire when you remember a walk through a sunlit street will spark again when you imagine walking it tomorrow. The brain does not store time like a clock or a film reel. Instead, it reconstructs moments from fragments, sight, sound, emotion, reassembling them anew each time. Every memory you hold is a story you've rebuilt from scattered light, rewritten in the language of the present. In that sense, Remembering is a kind of creation, and so is anticipating. We are not merely shaped by our past, we are constantly editing it, weaving it into what we expect the future to be. This power to move mentally through time is what gives rise to self-awareness. Animals can sense danger or recall simple patterns, but humans can reflect, regret, plan, and hope. We can stand at the crossroads of past and future, seeing both directions at once. Consciousness, some neuroscientists argue, may have evolved precisely for this, to allow organisms not just to react, but to simulate outcomes before acting. Each thought of what might happen is a small experiment, a rehearsal across possible futures. In this way, consciousness is not confined to now. It is an ongoing negotiation across the timeline of existence, an endless loop between what was, what is, and what could be. When the brain revisits the past, it isn't simply replaying data, it's reliving emotion. The hippocampus, which encodes memory, interacts with the prefrontal cortex to place experiences along a temporal map, while the amygdala colors them with feeling. Together they allow you to feel again, not just remember. That's why a scent can collapse years in an instant, or a melody can summon the ghost of a forgotten hour. The past lives in us as sensation, not sequence, and when the mind touches it, time bends inward. The same process governs our relationship with the future. The act of imagining what hasn't happened yet uses nearly identical neural pathways to recalling what has. The difference lies in the uncertainty. The brain must fill in the blanks, borrow details, construct possibilities from what it knows. This is why anticipation feels like memory turned inside out. When you worry about something, you are remembering forward, replaying what hasn't occurred as if it already had. When you dream, you are creating memories of futures that may never come to pass. In a sense, this constant oscillation between remembering and imagining makes each of us a living timeline, a being stretched across multiple dimensions of time. The self you are now is built from countless versions of you that still flicker in the mind's eye. The child, the dreamer, the regretful, the hopeful. Each one contributes to the illusion of continuity, the feeling that life flows steadily forward. But beneath it, consciousness flickers back and forth like a pendulum, touching the past and future thousands of times a day. Sometimes, when we lose this rhythm through trauma, illness, or age, the structure of time itself unravels. Memories slip out of order. The future becomes inaccessible. People with damage to the hippocampus often lose not only their recollections but also their ability to imagine. It's as if the same door leads both backward and forward, and when it closes, time collapses to a single, featureless now. And yet, even when memory fades, the brain's deeper rhythm continues. In dreams, we travel through time without effort, reliving moments or wandering into futures that never were. Sleep seems to reset our timeline, shuffling fragments of experience until meaning emerges again. Each morning, we awaken with a slightly revised map of who we are and where we've been, a new draft of our personal history, written overnight by the quiet hands of the subconscious. If we could visualize consciousness from outside, it might not look like a line of moments, but a field of connections, glowing threads between what was and what might be. The present is simply where the threads converge most brightly. Everything else, the memories we revisit, the futures we fear or long for, still exists in the circuitry, alive in potential. Perhaps that's why nostalgia feels so close to prophecy. They are two sides of the same temporal coin, one reaching back, the other forward, both anchored in the same mysterious machinery of the mind. The brain doesn't need a wormhole or a flux capacitor to travel through time. It does it every second, effortlessly, invisibly. In the quiet between thoughts, it slips through centuries of personal history and forward into infinite possibility, bringing fragments of each back to the surface as memory, dream, or decision. And perhaps that is the most profound kind of time travel there is, not escaping the present, but expanding it, until past and future fold within it, alive, breathing, and bound together in the single, miraculous awareness of now. In laboratories across the world, buried beneath mountains and oceans of data, humans have begun to bend time, not through fantasy or magic, but through precision. The instruments are not portals or machines of chrome and light, but vast rings of magnets, lasers the size of cities, and quantum computers humming quietly in sterile rooms. Each one is a whisper of control over the most elusive fabric in existence. The scientists working there don't talk about time travel in the language of paradoxes or science fiction. They talk about manipulation, about curvature, about wave functions nudged just enough to delay or reverse their evolution. It is not a leap across centuries. It's a gentle push against the current of causality. At the heart of this work are the particle accelerators, colossal rings buried underground, where subatomic particles are hurled near the speed of light. As they race through their circuits, time for them slows. According to Einstein's equations, a muon or proton traveling at such velocity experiences time dilation so extreme that its lifetime can stretch far beyond what it would be at rest. In those brief instants, time has already bent. Inside these machines, seconds become elastic, space folds subtly under the pressure of motion, and the rules of everyday existence yield to the deeper geometry of space-time. Each collision is a microscopic experiment in temporal distortion, a flash of pure energy revealing how the universe negotiates the flow of time. Then there are the laser's tools so refined they can trap atoms in light. With optical lattices and atomic clocks, physicists have begun to manipulate the flow of time on scales smaller than imagination. In 2020, researchers measured time dilation within a single millimeter. The top of a stack of atoms aged slightly faster than the bottom. The difference was imperceptible to the naked eye, yet measurable, proof that time is not universal, even within the same object. If you could live inside one of those atoms, you'd exist in a slightly different moment than your neighbor. What begins as an infinitesimal difference, given enough scale and precision, hints at something profound: that time is not fixed, but adjustable. Quantum simulators push this idea further. By manipulating entangled particles and controlling their environments, scientists have managed to make quantum systems evolve backward, reversing their wave functions as though rewinding reality itself. In these experiments, information flows in reverse for a fraction of a second before the system snaps back into forward motion. It's not a violation of physics, it's physics at its most delicate, a demonstration that the arrow of time can wobble when viewed from small enough scales. The equations that describe these systems don't forbid reversal, they allow it, so long as the conditions are perfect and entropy is contained. For that brief moment, time doesn't march, it shivers. And yet, these are glimpses, not gateways. Each experiment is like dipping a toe into an ocean we cannot yet cross. Still, the questions grow bolder. Could we ever warp time not just locally, but deliberately? If gravity can curve space-time, could we one day harness that curvature in a controlled way, compressing time in one region while expanding it in another? The mathematics says yes, at least in theory. The stress-energy tensor of general relativity allows for space-time configurations that twist, fold, and even loop back upon themselves. A strong enough field, perhaps generated by exotic matter with negative energy density, could, in principle, create a tunnel through space-time, a wormhole that links not only distant places, but distant moments. Some physicists call these hypothetical structures closed time-like curves, smooth loops in space-time that could allow travel from one point in history to another without tearing causality apart. In theory, information or even a traveler could ride that curve like a bead sliding along a thread. In practice, the energy required would dwarf anything we can imagine. A single gram of matter, bent into such a configuration, might demand more power than a galaxy could produce. And yet, we are learning to mimic the mathematics of those conditions in controlled settings. Laser interferometers, superfluid vortices, and curved graphene lattices can all simulate aspects of space-time geometry. It's possible that the first working time machine won't be one that transports us physically, but one that manipulates information, allowing signals to leap backward in a controlled loop, a message sent to itself, a calculation completed before it begins. The frontier between simulation and realization grows thinner every year. Quantum computers already perform tasks that seem to stretch logic, solving problems that should take longer than the universe's age to compute by exploiting interference across many possible timelines. Each qubit exists in superposition, exploring multiple futures at once before collapsing into a single answer. When physicists speak of these systems, they sometimes use the language of probability and sometimes, quietly, of time. Because what is computation, if not the deliberate steering of outcomes across a landscape of possibilities? If controlled space-time curvature ever becomes possible, it will not come as a sudden revelation, but as the slow convergence of these technologies. Particle accelerators will show us how matter behaves near the limit of motion. Lasers will teach us to sculpt time with precision. Quantum devices will let us reverse, pause, and entangle moments like notes in a symphony. The first machine capable of manipulating time may not look like a vessel at all. It may be an array of fields and frequencies, invisible to the eye but tuned perfectly to the rhythm of space-time itself. Perhaps, someday, a pulse of light will vanish into one chamber and emerge from another before it was sent, carrying proof that causality can bend but not break. And when that happens, it won't feel like defiance of nature. It will feel like revelation, the universe revealing a truth it's whispered all along. That time was never a wall or a river, but a fabric, waiting patiently for us to learn how to weave it. Long before equations described space-time or telescopes glimpsed the curvature of distant galaxies, humanity already felt that time was not a straight line. It was a cycle, a breath, an ocean that ebbed and flowed. Every civilization left behind stories that treated time not as a river with a single mouth, but as a wheel forever turning. The ancients, gazing at the same stars we do, sensed something in their motion, a rhythm too perfect to be random, too eternal to belong to mere mortals. In their myths, time did not begin or end. It repeated, endlessly, like the pulse of the cosmos itself. In Hindu cosmology, time is divided into vast ages called kalpas, cosmic days and nights, in which the universe itself awakens, flourishes, decays, and sleeps again. Each kalpa lasts 4.32 billion years, and when it ends, creation does not vanish but transforms. The gods themselves are caught in the cycle. Vishnu dreams the world into being, and when his dream ends, everything dissolves back into the waters of infinity until the next exhalation of existence begins. It is not destruction but renewal, a rhythm so ancient it makes even stars seem brief. In that vision, time is not something to escape, but something to harmonize with, an endless recurrence woven through the very fabric of being. In Buddhism, the wheel of samsara turns in a similar way. Life and death, gain and loss, joy and suffering spin endlessly, each birth a new revolution of the same cycle. The goal is not to break the wheel by force, but to awaken within it, to see time's repetition for what it is, and, in that recognition, find freedom. The cosmos becomes a mirror of consciousness, both caught in the same recursive flow. Modern physics, in its own austere language, is beginning to echo this sentiment. Einstein's equations suggest that time is not an arrow, but a dimension, that every moment past and future exists simultaneously in a grand cosmic structure. We move through it, but it does not move through us. Ancient Egyptians spoke of time in dual forms: Nihe, the cyclical time of renewal, and Dejet, the unchanging time of eternity. The first was the rhythm of sunrise and flood, of repetition and life. The second was timelessness, the stillness of the gods beyond decay. Together they described not contradiction, but balance, the same balance found in relativity, where the flow of time depends on one's motion and gravity's pull. Even then, long before clocks or calculus, humanity intuited that time was not uniform. A god's second might hold 1,000 human years. In the Norse Edda, time loops through creation and destruction as well. The world is born from ice and fire, only to fall in Ragnarok and rise again from its own ashes. The serpent Jormungandr circles the earth, biting its own tail, a perfect emblem of eternity that renews itself through its own ending. Modern cosmology, in its equations of expansion and contraction, hums with that same rhythm. Some theories suggest the universe might one day collapse under its own gravity, only to explode outward again in a new Big Bang, a cycle of births and deaths measured not in human generations, but in cosmic breaths. In Greek thought, too, time was divided into layers. Chronos, the measurable passage of moments, governed clocks and harvests. But deeper still was Ion, eternal time, circular and vast, the realm of gods and stars. Plato imagined time as the moving image of eternity, a reflection of perfection cast into the imperfections of motion. Today, physics offers a parallel, the block universe, where time does not flow but exists all at once, and our perception of its passage is merely consciousness sliding across the unchanging geometry of space-time. To the mind that can see the whole, there is no before or after, only a vast, simultaneous now. These myths and models, separated by millennia, converge on a single intuition, that time is not absolute, and that our experience of it is only a fragment of a deeper truth. The physicist describes it with equations, the mystic with metaphor, but both glimpse the same mystery. In one, space-time bends under gravity's weight. In the other, eternity folds upon itself like a serpent swallowing its tail. Both speak of cycles, of continuity, disguised as change. Perhaps what the ancients called reincarnation is, in another language, the persistence of information. The way nothing in the universe ever truly disappears, only transforms. The atoms that make up our bodies once belonged to stars, and the energy that fuels our thoughts will one day rejoin the cosmic sea. Energy cannot be destroyed. It only changes form. Every breath you take is shared with all who ever lived. Every photon of light that touches your skin began its journey in the heart of a dying star. The cycle never ends it, only changes rhythm. And maybe that is why myth and physics feel less like opposites and more like reflections of the same longing. To understand how something as fleeting as life fits inside something as vast as time. The equations describe the mechanism, but myth gives it meaning. Both whisper that endings are illusions, that beginnings are just returns. The wheel turns not because it must, but because that is how eternity moves forever, circling, forever alive. Stand beneath the stars, and you can feel it, the slow turning of everything, the same motion that carried your ancestors, the same that will carry whatever comes after. Somewhere between the kalpas and the equations, between the hymns of ancient temples and the hum of modern accelerators, lies the same truth, that time does not run away from us. It folds around us, endlessly, and we are part of its patterned dreamers, within a universe that is always waking, dying, and beginning again. Across history, stories of time travelers have drifted through the edges of human imagination, like fragments from another age, too strange to believe, yet too persistent to dismiss. They appear in photographs, in whispers, in unexplained encounters where someone seems to know too much or appear out of nowhere with knowledge that shouldn't exist. Whether dismissed as myth, hoax, or hallucination, these tales linger because they echo something deep in us, the uneasy sense that time is not sealed, that perhaps it leaks, and that some among us have found the cracks. One of the oldest such accounts comes from the late 19th century, when a man reportedly appeared in Times Square wearing outdated clothes and carrying coins minted decades earlier. He spoke of streets that no longer existed, of buildings that had been demolished long before his supposed arrival. When authorities searched for his name in records, they found no trace. A story too perfect, perhaps yet one that continues to circle through archives and campfire retellings. In another case, a photograph surfaced from the 1,940 showing a man in modern sunglasses and a printed t-shirt standing in a crowd dressed for another century. Historians examined the image, calling it an anachronism so precise it felt staged. But others noted that every detail, the camera, the film stock, the context checked out. Whether clever forgery or something stranger, it left the same lingering question. If someone could step across time, how would we know? The truth is, we might not. If time travel were possible, even in its most limited theoretical form, it wouldn't unfold as flashing lights or sudden vanishing acts. It would be subtle, hidden in probabilities and quantum interference. The traveler wouldn't stroll through a portal in plain sight, but slip between overlapping realities, slightly out of phase with our perception. Physicists call such shifts dimensional offsets, a hypothetical separation where an object remains present in space, but displaced in time by infinitesimal fractions of a second. Invisible to our senses, yet capable of influencing the world like a shadow overlapping another. If such travelers exist, they would not appear extraordinary. They would blend in perfectly, camouflaged by the same laws that conceal dark matter and quantum states. They could be standing beside us at a crosswalk, a step ahead or behind the moment we inhabit. Their watch might tick at a slightly different rate, their heartbeat caught between seconds, their reflection lagging by the tiniest shimmer. We would never notice because our senses evolved to process continuity, not cracks. We see motion, not the pauses between frames. There are verified anomalies that tease at the edges of this idea. In 2003, researchers studying a series of cosmic ray bursts detected particles arriving milliseconds before their theoretical emission. The discrepancy was so slight that most dismissed it as instrument error, but it wasn't the first time. Similar pre-arrivals had been recorded decades earlier, as if certain particles were capable of skimming backward through space-time before being born. These aren't time travelers in the science fiction sense, but they hint that causality itself is porous, that events may ripple in both directions along the temporal stream. If the universe permits such behavior at the subatomic scale, perhaps consciousness or technology might one day exploit it on the macroscopic one. Even now, we experience strange phenomena that blur our perception of temporal order. Déjà vu, that eerie sense of repetition, may be the brain's misalignment of time streams, a neural echo of moments arriving fractionally early. Prophetic dreams, quantum coincidences, sudden flashes of intuition, all might be microfractures in the continuum, glimpses of futures still crystallizing. If such moments can occur spontaneously in the mind, perhaps they can occur deliberately, engineered by design. Some legends speak of visitors who appear at critical points in history and vanish once their purpose is fulfilled. The Philadelphia experiment of 1943, though largely debunked, grew from rumors that a naval vessel had been briefly shifted out of time during a failed invisibility test. Witnesses claimed to see the ship phase in and out of existence, and when it returned, some crewmen were reportedly embedded in its hull, caught mid-transition between dimensions. No credible evidence survives, yet the story persists, retold with a strange consistency across generations, as if memory itself refuses to let it go. Modern sightings have adapted to the age of technology. Online forums document slips in digital records, people posting information minutes before an event occurs, timestamps that defy causality, data packets arriving before they're sent. Some are hoaxes, others artifacts of clock errors or transmission lag, but a few, defy simple explanation. To believers, these are traces of time travelers, leaving fingerprints in the network, subtle disturbances where their timeline brushes ours. To skeptics, they are coincidences magnified by human pattern seeking. Yet both agree on one thing: the anomalies are increasing. If time travel is real, it would not require countless travelers spilling through the centuries. One would be enough, a single explorer navigating the folds of history with precision and restraint. Perhaps they are historians, scientists, or even custodians ensuring the stability of events. Perhaps they observe, record, and retreat, leaving behind only whispers and blurred edges. We imagine them as interlopers, but maybe they are archivists of reality itself. And maybe that's why proof remains elusive. If their purpose is to remain unseen, then every failed attempt to find them might, paradoxically, confirm their success. The perfect time traveler would leave no trace, no ripple, no paradox, only the faint impression that something just beyond understanding has brushed past us. When you walk through a crowded street, glance at the people around you, the woman staring a little too long at a passing car, the man whose clothing feels anachronistic, the child who seems to watch everything as if remembering it. Perhaps nothing extraordinary binds them, or perhaps, for a fleeting instant, your timelines have crossed. And by the time you think to turn, they are already gone, folded back into the current of time, leaving only a silence that feels heavier than before. In the farthest reaches of cosmic imagination, there lies a moment so distant that even eternity struggles to contain it, a future so long from now that the word future no longer applies. It is the end of time, not as apocalypse or fire, but as stillness. No cataclysm, no explosion, no collapse. Just the quiet dimming of everything, the final breath of the universe as it exhales into silence. This is not a myth. It is a mathematical consequence of the universe's expansion, a fate predicted by the same equations that once revealed the birth of time itself. When the universe began, time was inseparable from heat. In those first incandescent seconds after the Big Bang, energy surged and churned in unimaginable density. Atoms had not yet formed. Matter and light were a single, glowing storm. From that chaos came motion, entropy unfurling, space stretching outward. Every second since has been a slow cooling, a vast diffusion of energy, from concentrated fire to endless cold. The stars we see are embers from that first ignition, still burning as the cosmos expands. But even they are finite. Their light will dim, their fuel will fade, and the night will grow deeper until it outlasts light itself. Physicists call this the heat death of the universe. It sounds dramatic, but it is not an inferno, it is entropy's final victory. As the universe expands, energy spreads thinner until every particle is evenly distributed across infinite space. No more gradients, no more temperature differences, no more flow. And without difference, there can be no motion. Without motion, no change. And without change, no time. Time, after all, is not a separate entity. It is the measure of change, the rhythm by which the universe evolves. If nothing happens, if every atom is as still and cold as every other, then time no longer has meaning. It doesn't end with a bang. It simply ceases to matter. Long before that stillness arrives, the cosmos will pass through haunting stages of decline. Trillions of years from now, the last stars will flicker out. Galaxies will fade into invisible clouds of cold matter, separated by expanding gulfs of emptiness. Black holes will remain for a while longer, slow eaters of the dying light, their immense gravity consuming everything unlucky enough to drift near. But even they will not last forever. They will shrink and evaporate through Hawking, radiation, dissolving their mass into faint whispers of energy. One by one, the great engines of creation will wink out, leaving behind only the ghostly background hum of particles too cold to move. At that point, The universe will enter what scientists call the degenerate era, a poetic name for a desolate truth. Matter will exist only as the faint remnants of decay, lonely protons, drifting in darkness. They will endure for unimaginable stretches of time, longer than any human word for duration. And yet, if current theories are right, even protons are not immortal. They too will disintegrate, leaving nothing but radiation too faint to form or interact. The cosmos will become a vast sea of nothing in particular, a place where the very concept of event no longer applies. In that era, the clocks, if any still existed, would stop ticking. There would be no cause, no effect, no distinction between before and after. Every second would be identical to the next, every point in space indistinguishable from every other. To any hypothetical observer, it would feel as though time itself had frozen, though in truth, it would have simply run out of things to measure. The universe, once alive with motion, would have reached thermodynamic equilibrium, the perfect stillness that is death by another name. Yet even in that vision of desolation, some theories whisper that endings are never absolute. Quantum fluctuations, those tiny restless tremors in the void, could spark new beginnings. Out of that timeless sea of stillness, a ripple of energy might spontaneously appear, as it once did in the beginning, and with it time, reborn. The same laws that allow universes to end also allow them to begin. The Big Bang may not have been the first, nor the last, but one in an infinite chain of expansions and stillnesses, births and deaths. If that is true, then time is not a line but a heartbeat, pulsing through cycles beyond measure. Still, the vision of the end remains humbling. Imagine a sky where no stars shine, where even memory has no anchor, where distance and duration lose meaning because nothing changes. It is not a place humans could ever witness, not even in dream or imagination. And yet, it is part of the same continuum we inhabit, the long echo of our own moment, stretched to infinity. Perhaps that is what makes the end of time so haunting. It is not destruction that awaits us, but stillness, a silence so deep it erases even the idea of waiting. Time will not stop like a clock reaching zero. It will simply fade into irrelevance. And in that final, frozen moment, all of history from the first flash of creation to the last heartbeat of a dying star will coexist as one eternal sculpture, complete, unmoving, perfect. The end of time is not the end of existence. It is existence without sequence, without rhythm, without story. A vast and silent eternity where nothing happens because everything already has. The final breath of the cosmos may not be a sigh, but a pause, a stillness so complete that even silence becomes eternal. And in that stillness, perhaps, the universe will dream again. You have been traveling through time since the moment you first opened your eyes. Every second, every heartbeat, every breath has carried you forward across the invisible current that sweeps all things toward what comes next. You are not standing still. You never have been. Even as you sit, even as you dream, your atoms are moving, your cells aging, your mind unfurling through the dimension we call time. The future is not a place waiting for you at the end of some road. It is something you are already passing through, moment by moment, without needing a machine, without leaving your body. You are, and always have been, the traveler. The truth is, we often forget this. We imagine time travel as something grand and external, stepping into a shining capsule, pressing a button, and vanishing into a storm of light. But the real voyage happens quietly, invisibly, in the folds of your own existence. The child you once were still lingers in your neurons, in the traces of memory that flicker when you recall a smell or a sound. The future version of you is already forming, cell by cell, thought by thought, somewhere up ahead. Between them stretches a corridor of seconds, and you are the pulse that moves along it. Each heartbeat is a measure of distance. The time between one breath and the next is a crossing, a small voyage through the sea of now. The mind, restless and curious, does not always stay anchored to the present. It slips backward into memory, forward into anticipation, looping through alternate futures and imagined pasts. Every day, you rewrite fragments of your own timeline, sometimes consciously, often not. The stories you tell about yourself shift slightly with each retelling. The past changes because you change, and in that act of remembering, you bend time in your own small way. If you close your eyes and recall a moment from long ago, your brain does something extraordinary. It rebuilds the scene from fragments stored across millions of neurons, reactivating the same sensory pathways that first recorded it. You aren't simply remembering, you're re-experiencing, stepping briefly back into that slice of space-time. The same is true when you imagine the future. The mind runs simulations, projects patterns, and constructs vivid worlds from possibility. You live in those futures as fully as you live in your memories. Consciousness, in this sense, is a time machine, not one that carries the body, but one that carries awareness itself. Science tells us that time is not universal. It bends near gravity, it slows with speed, it stretches and contracts depending on where you are and how you move. Two clocks can tick differently depending on their height above the Earth, their velocity through space. That means you, even as an ordinary human walking across a room, experience a slightly different tempo of time than the person beside you. Infinitesimal, yes, but real. Each of us moves through our own unique current, our own small stream in the larger river of the universe. And yet, beyond the physics, there is something more intimate. The sensation of time passing is not measured by clocks, but by feeling. Moments expand when we're afraid, collapse when we're happy. An hour in love feels like a breath. A minute in grief stretches into eternity. Time flows differently through emotion, as if the heart itself were a field that distorts it. You have lived entire lifetimes in a single glance, a single night, a single loss. You have stood still while years rushed by. You have blinked and become someone else. That is the human experience of time travel, the way the soul stretches across its own chronology, reaching backward and forward in the same breath. Every dream you've had, every plan you've made, every regret you carry, is a kind of motion through time. Even now, as you read these words, your eyes are catching light that left its source moments ago. You are always looking into the past. When you gaze at the stars, the light you see began its journey long before your ancestors had names. You are surrounded by time in transit, everything around you a record of what has already happened. You are both the observer and the evidence, the witness and the phenomenon. There's a quiet miracle in this realization. You don't need to escape the present to experience eternity. You are immersed in it. The molecules in your blood were forged in ancient stars that lived and died billions of years before you were born. Their ashes became the soil that became your body. When you breathe, you exchange atoms with everything that has ever lived. The past is not gone. It flows through you constantly, reassembled into new forms. The future, too, is not distant. It is being built right now, molecule by molecule, by the choices you make, the thoughts you allow, the kindness you offer. You are both the product of time and its architect. In the end, there may be no need for machines, no portals, no shimmering wormholes through space-time. The greatest journey is the one you're already making the voyage through your own existence. Every sunrise you wake beneath, every memory you carry forward, every dream you dare to imagine pushes the boundary of the future a little farther. You are the experiment, the explorer, the proof that time moves at all. And maybe that's the secret the universe has been trying to tell us all along, that the travelers we search for have always been here, that the machine we long to build is already beating inside our chest, that the future isn't waiting somewhere out there in the stars. It's unfolding within us, second by second, heartbeat by heartbeat, as we drift ever forward, not away from eternity, but deeper into it.